defined as the root of square of average in the reverse way. Now, physically what it means, it gives me the same power as if I apply the DC of that particular value. So you can also find out average over the half cycle. Full cycle, as you know, it will go to 0. Now we will apply one by one to different components. So it is actually refresher course. So it is, you are only going to refresh all these things. So I have here V and I in phase for resistance. For capacitor, so we have the value Q is CV, and you can take dQ by dt is C dV by dt, which gives me the current, which is C dP omega cos omega t. Now this cos omega t I can write down in terms of sin phi. So whatever is constant in front of this is the peak value. Then omega t plus pi by 2 will be pi by 2. Then it will go to, this will go to 90 degree, means it will go to 1. So this will be maximum. So that is IB is this entire value. But normally we know that IB is always VP by R. That means whatever is coming with VP, this C omega must be nothing but 1 by R. And that is why this is XC is 1 by omega C is the capacitive resistance. And if I look here, my current and voltage. Now otherwise also you can see here there is a difference of pi by 2. So my V and I are out of phase by 90 degree. And my current is first going to going to maxima, and hence the current is leading. Similarly, I can take inductor, and inductor we know L di by dt, okay, is nothing but V. So this L is gone down. Di by dt is Vp sin omega t. So you substitute for that, and so I will be given by this value. Again, you can see the sin omega t minus pi by 2. So here I is there, so I must be V into R. So therefore this omega L must be nothing but the inductive reactance. And in this case you can see my voltage is first going to peak, then before the current, and hence this is voltage here is leading. So normally we define reactance, which is a frequency dependent resistance part, okay, omega. Also you can say that wherever I have phase difference 90, it is reactance. Whether it is A and C, plus or minus depends on L or C. But the phase difference will be 90 degree, then it is a reactance. And when now I combine both resistance and reactance, I get impedance, and now there will be phase which will be different from 0 and pi. So this is what we have to remember, and with this we will go for different possible combinations. And before that, because I want to do those circuits with the help of phasor diagrams, so we should see what I mean by a phasor. What is a phasor? Now, this is my sinusoidal sine wave. Rather than showing like this, taking time axis, we can draw polar in the polar form, where the length of the vector gives me the peak value, that is V0. Whatever is this I0 or V0, that gives me the peak value. And this angle related to this time will be measured x-axis. Okay, and that is omega is here. So omega into t will be my this angle. And this, as this O moves on the circle, I go from here to here. So rather than drawing it like this, because it is repeating after 360 degree, I can always show everything like this. Using just a vector whose amplitude is giving me whatever is my AC, whether current or voltage, and it rotates counterclockwise. Now depending upon whether you take A is A0 sin omega t or cos omega t, you will get here the magnitude. Here the instantaneous value will be, in this case, since A is A0 sin omega t, so yours this value ON, this is projection, NP you project on this y-axis, so ON is going to be my instantaneous value of the voltage. If I take A0 cos omega t, then it will be projection on this x-axis, and that will give me the instantaneous value of the current or voltage, whatever is the quantity. So phasor diagram, if now I see for all three which we have done, VP and IP, both at the same time, at the same angle, and therefore omega t angle, and they are coinciding with each other. Next, in case of capacitor, what happens? Capacitor, the voltage is lagging, okay, by 90 degree. So whatever angle you take here, this should be 90 always. This is my V and this is my I, and the angle between them must be 90. Okay, and since V is V0 sin omega t, so therefore we have taken this as omega t. If you take starting as I equal to I0 sin omega t, then this will be omega t. Is that clear? Depending on whether you are choosing equation for V or I, you will show the omega t. So for inductor, Vp, here my current is going to lag and my voltage is going to, okay, therefore V is Vp, and again see this angle is going to be always 90 between them. So things becomes easier if we do using phasor angles or phasor diagram. So let's take simple RC circuit where we apply voltage V, which is sinusoidal. There is a current I, and hence we know that there will be voltage VR, VC, and we will apply always the voltage addition law. So V is equal to VR plus VC. So let me first draw VR. So always what you do is x-axis you choose as current first, and with respect to this current direction you decide all other directions. So my current is along the x-axis. Now I go first for R. R is in phase with my current. That means the angle must be 0, and therefore my VR I into this square root of. Now this has dimensions of ohms, and hence we call it as impedance. Impedance, which is now have two parts. Okay, so Z is the impedance, which is VRMS by RMS. So you can always write impedance of the circuit, and you can see that it is frequency dependent. You can also calculate the phase angle phi, which this is opposite and adjacent. So it is BC by VR or HC by R. So it's 1 by omega CR. Now these are the two equations. I can use them to find out my unknown value of capacitor, and also I can find out what is the value of phase phi. And that is what you are going to do in the experiment. So you will be taking VR and VC, take their ratio, which must be omega CR, that is 2 pi F CR. So if I plot VR by VC versus F, my slope is 2 pi CR. Okay, so C is equal to slope upon 2 pi R. So I can find out value of C. That is what is your experiment. So connect the circuit like RC, measure VR and VC at different frequencies, plot the graph, and do calculation, find out value of C. Now what precaution I should do when I am doing this? It seems easy, but when you practically go to do, how should you choose frequency? You can't say start from 0 to infinity. That takes so many readings. You can decide what is the order and where I want to take the readings. Not necessarily order. That will depend on value of C. It will depend on the value of C. No? So it's not necessarily audio frequency. So I don't know what is the C. See, when we are doing experiment in lab, when you are doing research, it's fine. You can start from 0, keep on doing up to infinity, find out what it is. But when we are telling student that take this reading, tomorrow student may ask why you are telling take from here to here. Why not? I want to start from 0. Why not that?
Capacitance, all sorts of capacitance are not available.
Yes.
Capacitance is certain range, like all sorts of capacitance are not available.
And given a capacitor, you take it 0.0. I'm giving you a capacitor. After that, what should I do? Practical problem. I'm talking about practically, not theoretically. Theoretically, you should take reading F is VC by VR by DC is 2 pi FCR. So from 0 to infinity, I can take readings. No problem. But when I am going to do practically, then what precaution I should take so that after one graph I should not tell student takes the range.
Time constant.
We have to see
the C already are by VC.
You are going to find out C. That is the purpose of the experiment.
R we know.
R you know.
We are by VC is not finite.
Yeah, that will be finite. It cannot be.
It has to be within the range I am talking. So that will determine my frequency.
So what range? You have come to a point, but what range? Now let me be clear. I am also teacher like you. So don't feel bad when I am asking questions. Because it is my experience that many small things we just miss it. It's not that we don't know, but we just miss it while teaching. So I'm going to point out throughout my all the days I am here, I will point out such things only which we are missing, must be added. And
coming from the electric circuits. If you are
I'm saying simple experiment. I have an oscillator, I have R and C, I'm changing frequency, noting down B, R, B, C. That's all. I should take certain precaution as a teacher. Because what happens if I tell a student he plots the graph and I'm not getting things properly, then I will tell him to play वापस से reading graph. अभी इधर से ले. So he may ask you why you are saying this now.
We have to choose to see that slope is not very small or not very large. The slope will have to be.
It doesn't matter because slope is whatever is the slope value, it's fine. There is measurement restriction. थोड़ा slow define करिए.
We have to ensure that the R remains relevant.
To XC.
Yes.
That is important.
Yes.
Your R and XC should be of the same order. Because my XC is 1 by omega C. So F. So at lower frequency it will just blow up like anything. It will be very, very large. And if I go to measure the voltage across R, it will go almost to 0. So it will be very difficult for me to compare one is in millivolt or microwatt and other is in volts. So you should choose the frequency such that XC is of the order of R. That means when you did not calculate all these things, you just put a meter and see that a sufficient voltage, if I apply 10 volt, then 2-3 volts should come across R and remaining across C, and when I change the frequency, it still remains rather than 2-3, it may go to 5-6. So it should be appreciable values which are comparable.
Here and B.Sc should be comparable.
Comparable. It should
That's
not
what I
be
meant. This is what I meant with the slope. Because the slope is dependent on the ratio of the other.
But that is holding like this.
Ah.
Then I have to again
I
go
was
back
doing the
slow
other
because of what, because of
I was also going to do the same.
same thing. That's what I say. You are very near. It is experimental. And
That should be comparable.
experimental means that with the multimeter when I go to measure, I should have a proper values in the same order. Then it is better. It will work otherwise also. But as a simple precaution, if you take near that 5-6 points, you will get excellent graph and values which will match.
Even while plotting the graph, we should be clear about the x and y components. When suppose we have to plot the graph in the case of resonance, we have the very frequency starting from very small to very high. Then we take the low graph over here, so that we can have a good graph.
That log graph I will discuss when I come to filters in detail. I'll see that sir is not there, log papers are there. All of you know how to plot semi-log this thing on the semi-log graph paper, which there is. It's there in the
No, it's not.
Many teachers are because who don't know how to plot.
Nowadays it's not.
Now normally directly go on Excel and do this. Okay, let's do the same thing for RL circuit. So we have R and L in series. Okay, don't write it. You can copy my all videos. Again, you can say that because it has 3 dimensions of ohms, so we call it as frequency dependent resistance, and hence it is impedance, called as impedance. So here we have V, which is leading by angle phi to the current. In this case also I have Z square root of this. Now normally what we do in our college is we plot Z square versus R square and take the intercept as omega square h. There this problem does come. If you don't take proper values, the intercept is so small, then it's very difficult to find out. But here we will be doing as it is given in your manual. So we have 10 phi dl by dr. So we have to find also this. So 10 phi is omega L by r. Omega 2 pi f. So again if I plot 10 phi versus f, I can get the value of n. Now in this experiment, what you are going to do is there will be a coil which has its own self resistance RL, and this is R of not load, R of the coil, and this is j omega because XL, because that itself will work like as a series. Then this j is the square root of -1. So the question of today is, what is operator j? What do you mean by operator j?
It changes the phase.
It changes the phase by 90 degree, positive, negative.
It will be positive for
So how do I show this student? So there is a real part and imaginary part, and I go to the complex plane. Let me take just one unit. So it is 1 here. If I multiply this 1 by j, what I get is j. So multiplying by j shifts it to vertical. So it goes from here to here. If I multiply this j once again, this j square is -1. So I go here. I multiply again -1 with the j. I get -j. I go down. Again I multiply by -j. It is 1. I come to this. So in terms of operator, it is doing the operation of rotating the vector by 90 degree.
Also you can write j equal to e to the power I by 2.
It is e raised to j omega t, that way.
No, but cos phi by 2 plus j sin by 2.
Yeah, that is theta.
Why term?
the same thing.
See, sometimes you have to use many different ways to tell student what it is. Since I have used the word operator, I have to show the operation. Since I am saying it is j operator, when it operates on something, what does it do? It is rotating that vector counterclockwise by 90 degree. That is the meaning of j operator. This we use because it's much easier if I take my voltage as e raised to j omega t rather than sin and cos, because second order differential equation comes in LCR and all that. It's very easy to solve if it is exponential. And at the end, because e raised to j theta we know it is cos theta plus I sin theta. Depending on what voltage I want, cos or sin, you can choose at the end real or imaginary part of that. So in this case, the impedance of this will be RL square plus omega square L square raised to half. So if I take voltage across coil, that I am VR square versus F square. You can see 2 pi L square by R square. That is this. So from slope I can find out the value of L. And this R is known, is the resistance which I am going to connect. Here still what is unknown? RL. Okay, so that also we will find out. Now we know applied voltage will be VR square plus V coil square. So 2 VR V coil cos phi. So I am measuring applied voltage VR V coil. Substitute that and find out cos phi. From cos phi find out what is tan phi. But tan phi I know is omega L by RL. So I can take 2 pi L by RL into F. So we will plot tan phi against F. And that will give me the value of this RL. So I can determine both RL as well as the value of L.
Not the resistance we have connected. No. But the phase will be determined by the voltage.
We are taking phase between what? I am saying phase voltage of the coil.
Only the coil.
So this is now when I take all the three components together. You know it's just drawn the voltage for R, L and C. The positive side phase, negative side phase. We know the values of BL, IXL, PR, IR, AC, ISC. So again, we know what is the phasor diagram for all three separately. Now here it is combined. So BC is down because it is 90 degree lagging. VL is 90 degree ahead. So you take the difference between the two, which is VL minus VC. So this is the reactance part. Then there is VR here. So these two vectors will add up together to give me V. And this is the phase difference between current and the final voltage. That is the applied voltage. So exactly similarly we can calculate what is the value of impedance V square VR square plus this minus sign because J is not used here. The phase is already taken into consideration.
Why do you refer of the 10 effective seconds? We do VL minus C all the time, not VC minus VL.
Anyway, it doesn't matter.
It's the difference.
No, but it is square, so it does not matter.
X minus X is equal to X minus
can also be larger than V.
Normally, see what happens because my phase is negative. My
Yes.
VC is negative side. So you show it that here
And
my
the
J is also
and the
coming.
positive.
Positive is XL
Excellent.
and negative is, so phase itself is taken care of. Then you take the negative.
Most of them will show VL minus VC.
That is the reason because XC is my negative. It's showing my negative phase. So negative sign is showing that it is lagging and this positive is leading. Mathematically it doesn't matter. But
And physically,
now it means like my phase is XC is lagging and XL is
no,
leading.
that's right, that is a mathematical part here.
No,
But
negative
inside-
sign is inside there is no difference. No. Here what I write will not make any difference to my circuit.
VC minus
I can write anything on board and on board will not make any
No,
difference.
we can have VC maybe more than VL.
That will be the-
Yeah.
we will be doing that.
Actually, most of the discussions we suppose the circuit to be like this.
Yes.
cluster and another?
Because I have a first order derivative relation.
See, that's a mathematical, but the physical concept might be.
Charge takes some time to build up so that the current flows. In inductor there is a fight. It is opposing your current. Suddenly.
Impedance is a resistance plus imaginary resistance.
It's not imaginary. Mathematically it is imaginary. That is my way to understand. There is a part which is frequency dependent and there is a part which is independent of frequency. This is the way to look at it. When I want to do mathematically, then I call it as imaginary part.
Another concept point is imaginary because the energy is not lost in the case of inductor and capacitor. That can be stored. That can be recovered.
But it's not imaginary in your imaginary dictionary word.
Right.
It means that I am using a mathematical tool, the complex plane, to explain the things. Because there is I, or whatever you say J. Physics people always use I. Electrical engineers always use J. So there is a difference. Otherwise it is same. So you use I just to say that I have something which is not in phase with my given current. And it is frequency dependent one. I have understood that. If you have some different idea, you can tell and discuss. So I can find out the total Z, which is square root of R square.
Why they use a J rather than I? Why engineer people use J?
I
Electrical engineer people right from beginning were using J in the notation in their reactants. But mathematics use I, and physics people follow mathematicians normally. And electrical engineers should follow physicists, but they don't.
They should follow.
They should follow. Slowly the technology is taking, going much ahead than science. The science people are getting neglected.
Basically, engineering is application of just physics.
They are surviving because of scientists.
Right.
Physics. But they are saying that physics is nothing, technology is everything. So that is why we are waiting for minima to occur. A day will come where the scientists will pass through a minima and there will be a need for scientists. And again science will start going up.
It has already started.
It has started. Not very distinct.
This is power of money.
It's
a power of money.
This is power of money.
Still it is very difficult to get jobs
They have
after
to
doing PhD in physics. So that is the reason people are not out. That's one of the points which we have to somehow, it's a hurdle, we have to move that. Unless there are jobs created after doing M.Sc physics or M.Sc PhD physics, except teaching or research, there is no other job. And teaching also, since the number is going down, teachers are not required. And all, since the education policy of India is changing, they are now inviting foreign universities. Those universities will not work on science. They will always work on technology, money oriented. So it's all universities run by the government has the responsibility of doing the science. And it is also that we teachers never talk about such things. We don't raise our voice that there is so much wrong things are going on in our education system.
Even we also want that our children should go into engineering, not in science.
No, but whatever it is, that is there. That I have.
Go have money and they are not getting so much money.
See, that is fact of the life. You need money to survive. You should accept that. After that, what the government is doing is not the right. The education level, like I don't know here what it is. In Maharashtra till 8th there is no exam. all students are passed up to it. So student doesn't come to class, he doesn't come to class and he says तुम fail तो नहीं कर सकते हमको.
This is implementation of
In
policy.
ninth they start studying. They don't know in multiplication division till ninth. Then 10th, 5 subject, any 5 subject you choose and do it and they get admission for 11 and 12. What is that? You are saying that they will do suicide. I am against that. Unless you train people to take challenges, they will never be able to take. You can't, government cannot give food. Service नहीं मिलेगी तो बाद में challenge तो होगा, tension तो तब भी होगा. So prepare them right from beginning. Give them stronger challenges. So that they are
Other
prepared.
societies have increased after this.
Because they don't know how to handle things. You have to teach them right from the beginning that this part of life. This is how we go.
Basically, they learn following meditation while they are swimming in
There is one more reason for it, and that is the modern parents. They think that our parents, they are not loving us properly, we should take care of them, and so they take over care of them. Spoon feeding is one thing, but shielding is there. आप क्यों रो रहे हैं? Sorry, मैंने गलती कर दी. These are not right things and right word to use. I do. Because you have to train them for the future. You should train person where you are, where you stand. That is a must. Okay. So now let me see all different values. This is my XC crowd is changing. 1 by F, XL, which is proportional to F, and this is R, which is constant. So here my XL and XC at particular frequency will cancel each other, and at that point only Z is nothing but R. And if I have coil which is non-ideal, then it will be R plus RL. That resistance also will come into it. So their Z is minimum. So we equate them, and hence the resonance frequency is 1/2 pi under root LC. So the Z minimum is R. You can see the resonance curve. Because my IRMS is VRMS by Z and it is VRMS by R. Z is R at resonance and hence IRMS is inversely proportional to R. So you can see that as I am decreasing the R, my resonance curve shoots up. So in this experiment also you will find out that Z, which is ZL and ZC, which is RL. This RL again I am talking of coil. So we are not going to take Z as the total circuit Z. It is only of reactive component, that is L and C. So here Vz by Vr will give me this value. And hence if I plot Vz by R against frequency, at this frequency, resonance frequency, I will pass through minimum. So you can, from here you can determine FR. So parallel circuit will also have similar thing, where my L and C will be parallel. So now what will happen? My impedance is ZL ZC upon this. Now this can pass through minimum ZL plus ZC, again XL and XC through 0. So this will have maximum. So this time impedance will be maximum at a particular frequency, and that is resonance. So this is the experimental setup. We have just one resistance, coil and inductor of these values connected in series. and take value across VR and VA. If you want R and C, then you short B and C. Okay, short these terminals and then you have RC in series. You remove them, then it is RLC, the resonant circuit series. If you want parallel, connect D to B and take C and A as oscillator. So there is R in series with parallel L and C. So using just a simple box, you can do all your experiments on R, L and C. These are the circuits.
Here we are taking L and C pattern only. But if you put R also in pattern,
It will give you Thevenin equivalent resistance. You will take R also, do the calculations.
typically we take the topic readings.
What readings?
If we put R, L and C in parallel in our topics, so we don't get the voltages in large, not to be. R has to be put in parallel with R in series with L and C.
That will depend upon if this total, because you have a one resistance I and R you are putting small, the total Thevenin equivalent will still go to very, very small value.
Not very small.
It will become very small. So you have to look always of Thevenin equivalent between that points. Or you can simply calculate LC parallel and then put that in parallel with R. So it will reduce that R further. And that will make the value very small.
Very small. This is the potential problem here.
When we do the frequency, there
What he is saying is here, that part. See that part, last part, there is current again increases. Current again increases. This part. This part. This part again current goes down.
Yes, it will happen because
Stop this thing.
you have R and this is the circuit. What we are doing is we are applying a voltage V against the circuit. Total current I will be V by R plus ZL ZC is R. So V by R plus ZL ZC by ZL minus ZC. This will be the current. Okay. Now at resonance ZL equal to ZC. Therefore this becomes, if the coil had no resistance, ZL omega L will be equal to 1 by omega C at resonance. But if the coil has a resistance, ZL minus ZC will be the resistance of the coil, because the impedance due to inductors will cancel out impedance due to, therefore this will have a minimum value and therefore this will be maximum. Okay, therefore the current will become minimum at resonance. When you go away from resonance, this will come down from the maximum value. So current will increase. So your impedance will be a maximum at resonance. That means current will be a minimum. As you go away from resonance, impedance decreases from maximum. So current will fall.
No, he's not
But
making
case of
it.
series-
See, I have to
Series RC are there.
See what we are measuring is, what I am measuring here is impedance.
But you have taken the parallel resonance circuit. I am asking of series.
Series. Okay, if you ask me,
Sir, he is asking after resonance, again the current is increasing. He is asking that.
series resonance.
Yes, series resonance.
Series resonance. Right. In series resonance, this is B plus by R plus ZL minus ZC. ZC is 1 by J omega C. I write as minus 1 by J is minus J. So at resonance, ZL will be equal to ZC. So your current will be maximum. Then the current will come down. Then
But the problem for impedance is
the impedance is minimum here. The impedance, I am plotting impedance. Impedance is minimum. Then the impedance will increase. That means the current will come down and then it will reach a steady value. But what will happen is, if you go to very high frequency, then your coil and your resistors that we put, their values will change because of skin effect. Skin effect at very high frequency. Your current will flow only through a layer close to the surface, not deep in the surface. So the inductance will change, it will not have the original value. So we limit ourselves only up to 7 kilohertz. We don't go more than that. Okay?
Why physically this is happening? Physically, how it physically happening?
Scale factor. I should see the scale factor.
Physically, what is happening? Physically, what is happening?
Physically, what is happening is, see, series resonance, ZL is R plus J omega L. Okay? So you apply a voltage V. So this is R. That is, I am taking only the coil. This is the resistance of the coil. This is omega L and this is J omega L and this is minus J omega C. So if you take the current along the x-axis, then the voltage across the resistor will be IRL in phase with the current. The voltage across the inductance will be omega L into I, 90 degrees leading. Voltage across capacitor will be I by omega C, but it will be 90 degrees lagging. Now when you don't have, you are not at the resonant frequency. Suppose omega L is more than 1 by omega C. These two won't cancel each other out. Therefore, the sum of these two will be as this is O, A, B, this is AC. AB is not equal to AC. Therefore, you will get a result at AD and the total voltage will be this value for the same current. But at resonance, AD will become 0. Therefore, the voltage will become a minimum if you keep the current constant. So, for a given current, voltage will become a minimum, or for a given voltage, current will become a maximum.
This is due to PS.
That is what is happening. See, any other questions?
Ma'am, still I am not
Okay.
clear about this thing. When all three components are connected in parallel, what will happen? Yes, when all three
Skin effect arises because your material has a conductivity. So, if you write the conductivity will prevent the electric field. The electric field at the surface of the metal will decay into the material. It won't remain